All right, in this video, we're going to find the area function using the trapezoid method. So to be clear, the trapezoid method is only going to work for a linear function because a linear function has an area. When you make the area with the bounds and the x-axis, the shape that is formed is a trapezoid. So this method would not work if you had a parabola or a log function or a sine wave, really any other graph. But it is going to help us to notice some patterns and make some discoveries that will help us for all functions. So let's just start with the basic area function. And that's when you start at 0 and you just go to any point. So what we're saying is if we were to kind of pick an arbitrary point x, I'm not even going to name it anything. I'm just kind of going to say if it were x, I want to find the area that starts at 0, ends at x, is bounded on the bottom by the x-axis, and is bounded on the top by the, we say the curve, but by the function. So by the function f of t equals 2t plus 3. So what we would do then is we would, again, consider that this is a trapezoid. On a trapezoid, to find, sorry, I realized I didn't finish writing this. It would be f of t dt. All right, so again, this gives me all the bounds. So I'm starting at 0, I'm ending at x. F of t is the function, okay? And what this really is, we'll have another video on exactly how to read this, but this is just the equation for finding the area. So in order to actually write this equation, in order to actually find it, a rule, a function that's gonna work for us all the time, we'll consider that this is a trapezoid. So in this trapezoid, you add the bases. I know these bases look like heights here, but the two bases always have to be parallel to each other. So it's kind of like a trapezoid on its side. This one is going to be 3. I got that because it's just the y-intercept of the function. To get the value of this side, it's equal to the coordinate, the y-coordinate of this point. So if I plugged in x into this function, I would get the height of this side or this other base. And then the bottom just comes from the value of x. Whatever x is gives me this distance down here. All right, so that means that using the area of a trapezoid, I can say that I would add 3 plus 2t plus 3 over 2, that's the formula of the trapezoid, and multiply it. And sorry, it shouldn't have been a t, I got distracted. It should have been an x because we're plugging x into the function. So both of these should be x's. Okay. So now to simplify that, I get 2x plus 6 divided by 2 times x gives me x plus 3 times x gives me x squared plus 3x. So that's my area function if I want to start at 0 and end at x. Now, what we want to consider is what would happen if instead I want to find a different area, and instead of starting at 0, I start at 3, and then I end at x. So we're not always going to start at 0. We're going to try and find areas under curves where we're not necessarily, our bounds aren't from 0 to whatever number. So I'll just kind of erase this little piece right here. Let's say instead I start when x is 2. All right, so that changes some things. What it does not change is this height over here. So the height of the side here is still, you plug x into the function, you get the height over here. This height here comes from plugging 2 into the function. So 2 times 2 plus 4 is 7. And then the most important thing, I think, and the piece that maybe is the most difficult, this part down here, this base, is not equal to x, because x is the distance starting at 0. But we shifted over 2. We got rid of these 2 points. So this blue line is actually equal to x minus 2. Whatever x is, subtract 2, and that will tell you the difference or the distance. And that wasn't a mistake. I said that on purpose. The difference is the distance, but the distance between 2 and x. So if I went to write that function, instead of 3 at the start, I now start with 7. I still add 2x plus 3 as my other side. I still divide by 2, but now the base here that I multiply by is x minus 2. All right, so 7, 8, 9, 10 plus 2x divided by 2 times x minus 2 is 5 plus x times x minus 2, which gives me this function, b of x equals x squared, 5 minus 2 plus 3x minus 10.